Congruency. Triangle ABC has been reflected over the y-axis. What is known about the relationship between the measures of the angles of these two triangles? Even without them telling us that this was a reflection, we can see that it's a reflection, because if you look at point A and point A prime, you can see they're the same distance from the line of reflection, which is the y-axis. They're each one away, right? One's on the right and one away on the left. Same thing goes for point B and point B prime, right? They are each, let's see, 1, 2, 3, 4, 5 units away from the line of reflection, just in opposite direction. So we can, besides them telling us that this is a reflection, we can see that it's a reflection. But it's good that they told us that it's a reflection, because anytime we use a reflection, a rotation, or a translation, we don't change the size of the figure. We just move it to a different location. So the figure that results from a translation, a reflection, or a rotation will always be congruent to the one that it came from, right? To the previous image. So pre-image is before the transformation, and then image is after. So with those three transformations, the image is always congruent to the pre-image. Those three transformations are called rigid transformations because they don't change the size. So what's known about the relationship between the measures of the angles? They're congruent, right? Angle A is congruent to angle A prime. And then angle B is congruent to angle B prime. And angle C is congruent to angle C prime. And I'm not using 1 mark, 2 marks, 3 marks because it has anything to do with the size. I'm just marking them so that they're the same, so that congruent angles have the same markings. So the angles in the triangle that was formed through reflection will have congruent angles to the one that it started with. What pair of transformations was performed on EFGH to form the image? And we have that both of the polygons are shown here on the grid. So if this segment right here, segment EF, ends up right here, then that looks like a 90-degree rotation to me. But if I look at where E is positioned, it's 1 away from the x-axis and 1 away from the y-axis. This E, though, is 1 away here, but it's 2 away here. So it looks like after I rotate, right, if I were to rotate this figure, then it's going to end up with vertices E and F are going to be right here, or E prime, F prime are going to be right here and right here, right? If I start here and I rotate this green segment, when I rotate it, it's going to be right here, right? That's after a 90-degree rotation, it would be right there. But that's not where my figure is my figure is translated 1 unit up from that. So I would say that the pair of transformations here would be a 90-degree counterclockwise rotation and a translation 1 unit up. Now there is another option. What if we translate before we rotate, right? So let's see what that would look like. So what I could do is I could translate my polygon EFGH so that it's here, right? And then when I rotate this new polygon 90 degrees counterclockwise, it would rotate to right here. So the other option, so actually let me go back and write the previous option down. So what we did last time was a rotation 90 degrees counterclockwise. Sorry, that's supposed to be a CC. Followed by a translation, and that was 1 up. So up 1. Now this other way that we could do it, if we do the translation first, we could do a translation 1 to the right, or let's say right 1 unit, and then rotate 90 degrees counterclockwise. Either way, those two transformations will take us from the pre-image to the image. All right, similar question. We've got polygon TUVW, so the pre-image and its image are shown on the coordinate grid. What pair of transformations was performed on TUVW to form T prime U prime V prime W prime? So we have to look for which one is the original first, right? So it looks like this one on the right is our original. So I'm going to look at distance, right? Because that's what I looked at the last one. How far away are these figures from the axis? So this point T, for example, oh wait, I don't want to make it white. This point T is 3 units away here, and it is 4 units away if I look at how far it is from the x-axis. The figure on the other side looks like the one that I started with, but it looks like it's been flipped over, right? So if the figure looks like it's been flipped over, that's a reflection. But if I were to take this figure here and flip it over the y-axis, then we know, because we have studied reflection properties, that it would be 3 units away. So it would be right here, right? But it's not. It's 2 more units to the left. So let's do the reflection first. If we do the reflection first, then we would reflect over the y-axis, and then the second thing we would do would be to translate 2 units to the left, right? So that would be the second transformation. We would translate, so I'm going to put then translate left 2, right? Now, just like the last time, we could do the translation first and then the reflection. So let's see what that would look like. Let me get rid of this. Okay, so if we want it to be, let's see where we want it to end up. We would like it to end up 5 spaces away from the y-axis. So in order to get this point T 5 spaces away, I would have to move it 2 to the right. Now my point T would be here, so now when I reflect it over, it would be in this spot where I want the image to be, right? So for this, if I want to do the translation first, I would translate, and that's going to be right 2, right? And then I would reflect over the y-axis, right? And put then. So 2 different ways that I could do it, but the same result, and using the same transformations, but the difference here is whether you translate first or translate second, that decides whether you're shifting to the left or to the right. All right, and then triangle LMO was reflected to form triangle L prime M prime O prime. How would you describe the relationship between these two figures? This is very similar to the first question that we looked at. If one triangle was reflected to form the other triangle, that is a rigid transformation. Just as a reminder, there are 3 rigid transformations, right? We've got reflections, rotations, and translations. Right? So reflect, rotate, translate. Any of those 3, and then the figure that's created will be congruent to the original. That's it.